Okay, guys, let's take a look at our quiz review for thermodynamics. Okay, so number one, well, it's before number one. Identify the following in the graphs above. So these two graphs. What's the potential energy? What's the potential energy of the reactants? What's the potential energy of the products? Where's the activation energy? And is it exothermic or endothermic? Okay, so let's look at the first one. Here we have reactants, and here we have the products. So this is the potential energy of the reactants. If there was a number here, you could read it. And here's the potential energy of the products. If there was a number here, you could read that one too. And up here is the activation energy, the little hump. And we're going to talk about that a little bit later in the next unit. Okay, so we have reactants. They're going to products. Look, it's going downhill. Notice this little arrow here. If it's going downhill, it's exothermic. Here, this one, it actually says, if you look really closely, reactants over here. It says products over here. And look, it's going uphill. So it's endothermic. And of course, if you're asking about that activation energy, it's marked there too. That's this little hump over here to get over the hump. Okay, so for here, it's going downhill from reactants to products. Don't worry about the bump. From up here to down here, it's going downhill. That's exo. And here it's going uphill. It's endo. Okay? Now, this is going to be interesting. We'll talk about this in a little bit at the end. Here we have some definitions, which hopefully you did and you remember from your definitions that you had already. Exothermic is a reaction that releases heat, and you can tell because it gets hot. Endothermic is a reaction that absorbs energy. It gets cool. So here we have our exo and endo. Exo is going downhill. Endo is going uphill. Activation energy, that energy needed to start the reaction. That's that hump up here to start the reaction. Okay, so where does chemical energy come from? Well, if you looked at the PowerPoint, it's from making and breaking bonds. So that's where the chemical energy comes from. Now, let's talk about the different types of energy. What type of energy we get from our food? Yum, yum, yum. That is actually chemical energy. We are eating chemicals. Our body is making and breaking those bonds, releasing the carbon dioxide, absorbing the oxygen, releasing the water. So it's making and breaking chemical bonds. So that is where we get our food energy from. Maybe I'll show you a nice demonstration on that. Okay, what is kinetic energy? That is energy of motion, and potential energy is stored energy. So you can actually see here on the graph that potential energy here is stored in the chemicals, just like potential energy is stored in your food. And then when you burn that, you get kinetic energy. And you also get thermal energy. What's thermal energy? That's heat energy, which is based on particle motion. That's a C, by the way, just in case you're complaining about my letters. Particle motion. What is nuclear energy? Well, that's way back from the beginning of the school year. That's energy that's stored in the nucleus of the atom. That's where nuclear bombs come from. Okay, what is electrical energy? That's energy from the flow of electrons. So now we're getting all of these different types of energy. We get the chemical energy, kinetic energy, potential energy, thermal energy, electrical energy. Wow, so much energy. So where do we get the law of conservation of energy? That means that energy cannot be created or nor destroyed. Okay, so energy is energy. It can only be converted between these different items. But Mr. G, what about nuclear energy? We'll talk about that later. Or we talked about that before. Not really important. Next, let's look at two types of reactions. Here we have carbon plus oxygen makes CO2, which is burning of charcoal. So what's happening? Look where that energy is. It's on this side. It's a product. The energy is coming out. If the energy is on this side of the arrow, here's the arrow, it's a product, which means you're making it. If you're making it, the energy is coming out. If the energy is coming out, it's exo. And I wrote exothermic here. And look over here. Here we have water plus energy makes hydrogen and oxygen. Mr. G, that's not a balanced equation. Yeah, whatever. Okay, so we have energy is on this side of the equation. It's going in. It's a reactant. It's going in. So the energy is going in. That is endothermic because the energy is going in. Okay? So here we have a little formula with energy going out. And here we have a little formula with energy going in. So this one is exothermic, energy out, which, if we slide all the way up here, look, this kind of reaction. That's exothermic, energy coming out. And here we have the endothermic, energy coming in. And by the way, if you notice this little equation on the bottom, which relates to this one, here we have lots of stuff. Oh, look, here's the KJ. This is the energy coming out. That's a product. So energy coming out is exothermic. Got it? So you need to know what the little charts look like. You need to know if it's going uphill or downhill. And you need to know where the activation energy is, that little Humpty Dump on the top. And all the different types of energy, which is pretty easy stuff, hopefully. So be ready for the quiz